Hola, SAP developers. Welcome to this session, part of the DevToberfest 2023 integration track. This will be an exciting session where we will be learning about developing applications with SAP Graph. Today, we have Shardul, who is a colleague of mine and a developer part of the SAP Graph team. So please feel free to drop us your questions on the chat window as we will be monitoring it, and we will answer your questions then. Without any further delay, hola, Shardul, over to you.
Hello, everyone. Thanks, Antonio, for introducing me. Today, we will be taking a look at how to develop an LLM application with Graph in SAP Integration Suite. So I will straight away jump to the agenda and let's take a look at the. So the first part is we will take a look at the introduction to Graph. So what is Graph and how to create a business data graph? There's a demo for that. Then we take a look at the large language model use case and how contextual learning with API metadata works. And then we take a look at the demo that is the command line application that I've developed using OpenAI and Graph. At the end of the session, we will know that how the precise metadata from Graph is useful for developing LLM applications. And we will learn that, how Graph, the way it simplifies the life of a developer, in the same way, it would simplify the life of a large language model to train itself and give precise answers about the product. So let's now jump into the first part, that is introduction to Graph. So what is Graph? So I will first start with let's give me a second. Okay, now I have it. So I will first start with the enterprise landscape. That is the problem statement. So we have enterprise landscape and on the left, and also extension apps. So now what problems do enterprise landscape face? So they have, as you can see, they contain multiple data sources, for example, CX, S4HANA, some custom systems. Some of these could be on-premise, some of them could be on cloud. And since SAP has acquired multiple companies over the period of time, there is a possibility, or the problems that enterprise landscape faces, that they have replication in some of these systems. This becomes very difficult for the enterprise landscape people or the enterprise IT to explain the developers what entities they want to expose. And therefore, it's also difficult for them. Another problem for developers is if they are trying to build extension applications. So now we are switching the roles. Now we have a developer, and imagine that you need to connect to all of these systems. So each of them then uses a different security protocol and to connect to these systems. And even, as I said, they might have some replication. So it's not very clear for them to develop API applications. What are extension applications? So basically, they are extensions towards to the traditional SAP systems. So you can use the traditional SAP system and some custom data source and combine them and create an app over it. So let's take a look at what Graph is trying to solve. Now, with Graph, we can have a semantically connected SAP data system, and we call it a business data graph. So how does it solve the problem for enterprise IT? So they can create a business data graph which contains only the entities and the attributes that they want to expose to the developers. So they can specify the business use case, they can expose the attributes and the entities that they want, and create a very nice semantically connected business data graph and hand it over to the developers. And how it solves problems for developers is developers get, so at the end of a business data graph, developers get an API which contains the information that they need to create. So they can only focus on developing the extension applications and not worry about the semantics of the data. They even, so with Graph, you get an OData or a GraphQL API. So OData is nothing but REST. So basically it is so these are very standard protocols, and developers know OData and GraphQL languages. So to develop apps which can talk to these APIs. So it simplifies the life of both developers and enterprise IT. Now let's take a look at how we can create a business data graph. So for that, first we need to configure a business data graph. And then what we need for that is you need data sources. So these are the data sources that you can see in the picture to the left. And these are configured in BTP in the destination service. The next part is now we take a look at the entities that we are going to expose in our data graph. The first type of entities are mirror entities. These are nothing but projections of the source entities. So for example, S4, so it simply will contain a projection of S4. They will have the same attributes that are reflected in the mirror entity, but only exposed via graph. Now, the next concept is the unified entities, which are nothing but a standard set of entities which contain a standard set of attributes. So these are what we think are standard attributes which are exposed in the data graph, and at the end they might contain the data from different source systems. But for example, let's take a look. Let's assume that we have business partner. So they will contain attributes from business partner and some other source system, and at the end make a composite view of the business partner. Now, in some cases, customers want some custom entities that they say, okay, the unified entities are not enough for them, and they want a very specific use case, so they want to develop a custom entity. So this is where Graph supports creating custom entities, which will also contain the data from multiple data sources, but the entities are designed by the enterprise IT, so they can control the way they are structured. So this gives a lot of control to the enterprise IT. Now let's take a look at the part of custom entities in detail, because we will then see how to do it in the demo as well. So we also call it custom model extensions, and it contains of three types of extensions. First is a projection, second is composition, and third is connection. So if you can see to the picture here, so these letters are basically attributes in a particular entity, and in the case of projection, they are basically the same attributes. They're just, for example, renamed here. So if you can see, this is the original data source, and then attribute is capital A, and it is renamed to small a, just so that it looks cleaner. So this is an example of a projection. In case of composition, it's data from two different source systems. So if you can see, A here is the common one, and B is from the first one, and G is from the second data source. And at the end, we have a connection, which is nothing but a link from one data source to the another. And it's basically, so for example, here the underscore D is a link to the D here, and so this is how you can establish a connection in a custom model extension. So we will now take a look at how to do that directly. So we need to create a JSON file for that, and I will show you how to do it in the demo itself directly. So let's consider an example that you are an airline company and you have some business partners, and you have the database of frequent flyers. And we need to create now a custom entity which will represent the name of the business partner, the cities, and also the frequent flyer information in a single business data graph. So this is the example that I was talking about. Here you have business partner. So the business partner information is stored in an S4 system, and the frequent flying information, which contains the frequent flyer points, is stored in a custom data source. So this is called as my.custom. And we will now create a new custom entity called as company.flying-partner, which will contain data from both of these systems. So as I explained earlier, we first need source entities. So these are the source entities that we need. So first is business partner. This entity contains these attributes. So these are not the only attributes that an S4 system would contain. It might contain more, but for the sake of this example, we have reduced, or we are just using a subset of them to show here. And this is the frequent flyer example, where it contains the details about business partner, loyalty program, and everything. Now, this is the target custom entity that we want to develop. So it will contain custom names, but at the end, the information is from either of these source systems. And we can do some complex operations, for example, negation or add a dictionary or something like that, but we will take a look at it now. So as you can see, the following attributes are now taken from the source entity business partner. For example, the name, if it's active or not active, and the location, which is taken from business partner address. And the others are taken from the my.custom. So if you remember, this is an example of a composition where you take entries from both the source entities and bring it into one. So this is a nice example of composition. Now let's take a look at how the JSON file for that would look like. So the name of the entity is company.clientpartner. Then you have defined the source entities, which are both of these, and the key is the business partner in both of them. So this is the business partner, and this is the link between them. And at the end, you define the attributes, for example, the location or the membership points, and this is where they're defined. So if you are a developer, maybe this makes more clearer how it's defined and how the entire thing works. Now, let me switch the context, and I will move to the browser where we do this, and we create a business data graph with company.flyingpartner. So let's switch there. So now I'm okay. I think I signed out. So let me sign in again. So now I'm at the SAP BTP cockpit, and I'm using a trial account where I have SAP Integration Suite installed, and also a graph instance with the Plan API. So let's take a look at the destinations first. So now I've switched the tab and I go to destinations. So here you can see I'm on the destinations, and these are the two destinations that I've defined. So first was the frequent flyer, and the second is the S4 system. I've mocked these systems so that they work perfectly fine, but in general, this is a public endpoint, or you can use your own data, and this is the same data that comes from an S4 sandbox, which is available in the SAP API Hub for public use. Now let's jump back to SAP Integration Suite, and I click on the link here, but I don't do it because I have already opened it. So this is let me reload the page just to be sure. Okay. So this is the graph user interface that looks like, and here we can design a new graph. So let's take a look at the model extensions, and let me create a new one. So this is the file that we just saw in the presentation earlier, that I want to create a model extension. So I call it and then we select the file, but I will just simply drag and drop it. I say create. And now let's create the business data graph. So what we do is new business data graph. ID is again. So this is just an ID. We can give any name here. I just gave company and selected all. And next, and we select the model extension. So we just created company.flyingpartner here. And next. So what's happening now? So it reads the model extension file, and it then decides what will be the rules and how the endpoints will look like. And at the end, it comes up with a config file. And this is how it looks like. So it has two data sources. One is the my.custom, and the other is S4. And it contains these are the rules. So there's an SAP.S4, there's a URL for SAP.Graph. So this is the unified entity URL. Then this is the URL for the custom entity, and this is the company.flyingpartner. So this is the one that we just created. That's the new one. And if I say create now, so what's happening now? It's creating a new graph instance in SAP Graph's cluster, where it will have a new execution unit, which will basically be responsible for taking your request to the downstream systems, and at the end creating the fetching the data. But now I already have it once. So this is called a demo. It's created using the same set. And since it takes maybe a few seconds, I will simply jump to the graph navigator to show how this looks like. Okay, so we have two business data graphs. This is company, this is demo. I will simply continue with the existing one. And if you see here, it contains multiple types of entities. So for this, the SAP.graph, this is the unified entity I talked about earlier. Then SAP.S4, this is the mirrored entity. Company, this is the one that we just created, and my.custom, this is the original entity which contains the frequent flyer data. So we will take a look at the company.flying partner, because this is the one that we just created, right? With the set of attributes that I just showed, and if you expand locations, you see the details here. Let's take a look at Trap. So Navigator is nothing but an HTTP client. You don't need to worry about the security details here, because it's linked to your sub account in integration suite. So that just simplifies your testing. So let's run this query, company/flying partner $top equal to 1. And I can see that we can expand here. So we do expand with location. And now if you see here, you see the city details as well. So this is very standard OData stuff. Okay, now I'm done with explaining the graph part. Now let's take a look at the interesting part as well. This is the second half of the demo, which is contextual learning and how to develop an LLM application using that. So now I'm going back to the presentation. Here we are, and I jump to the next slide. So what is contextual learning in an LLM? Contextual learning enables us to steer the behavior of an LLM for desired outcomes. What it means is that let's take a look. Let's think this through with an example. Imagine that you are a business owner and you want to know what was the amount of sales that you made for today. And then you can simply ask this question to an LLM model and say, hey, tell me the sales that we made today. Of course, the LLM model doesn't know anything because it's not trained with your data. If it's trained, that's a different scenario. But now imagine that it's a generic LLM model like OpenAI GPT 3.5. It doesn't know anything about your company. So you need to give it a context. And now let's think that we give the LLM a context saying that, okay, we made 3 sales today. First was 100 euros, second was 500 euros, and the third one was 500 euros again. So at the end, I would expect an answer of 1100 euros. So I'm giving the context here, and at the end, I'm expecting the result saying that, okay, you made sales worth 1100 euros today. So this is the concept of contextual learning. Now we will take a look at how to use it in the context of graph, and where does graph play a role in this entire scenario. So let's again consider the frequent flyer example, and now we want to know the answer to the question, give me the flying partner with maximum membership points. So this is a very specific question. Again, the same thing applies, that the LLM model doesn't know that what's your frequent flyer data. So what do? Is we again give the context, and in this case, we give context in the form of OData metadata. So what is OData metadata? It is similar to an OpenAPI specification, which contains a list or details about the attributes present in a particular API. So it's basically a raw information about the API. So in this case, what it will know is we send the EDMX metadata for the newly created entity, that it contains ID, then it contains the name, it contains the address, the location, the city name, and at the end, the frequent flyer points. So we tell that, okay, this is our API and this is what it contains. Now what GPT 3.5 can come up with is a nice query saying, okay, you can execute this query to graph or to your API and get the result. So this is where contextual learning comes up. And then I would think of another question which comes up in my mind is, then this can be done with any OData API or any API which has an OpenAPI JSON as well, because you can give an OpenAPI JSON file as well. So why graph? And the answer to this is with Graph, Enterprise IT can design very precise APIs. And if the APIs are not super precise, then it's difficult for the model to learn about the context. There's also another factor to it, that is cost and the size of queries. So if you have some unwanted data in the metadata in the API, and it contains some unwanted fields, the size of the metadata is huge. And if it's huge, then you need to add some algorithms to shorten it and then send it to the chat model. Otherwise, it won't be able to answer, or it will be very slow. And if the size of the metadata is higher, the prompt size is more, and you have to make more expensive queries. So this is where Graph plays a role. Now, coming back to our example here, we get an answer saying, okay, the frequent flare is fast spikes INC. So it looks a very simple example, and now we will take a look at how this looks in VS Code. So I will now jump to the demo. So if you want, you can scan the QR code, but this link is also available in the chat information below, so you can take a look later as well. So now I will jump to the browser to take a look at the GitHub page. So this is the same GitHub page that I added the link for, and we have the following README file, which contains the prerequisite information and the command and some sample questions. So what we need, first step is we need a business data graph. We just created one a few minutes ago, and we saw how to do it. Then we need a credentials.json file, which is the secret file which we saw in the BTP trial sub-account for your API plan. And we need an OpenAI API key. So this is a key which I have generated from the OpenAI documentation. I have an account there, and it's all generic, so anyone can try this out. Let's for now copy the Python file, which is the command to run this code. And I will now again jump to VS Code so that we can run this. Here we go. So here we have VS Code. Let me close everything again, and so let's take a look. Okay, now I've just pasted the command, and let me run it. So I will expand it, make it a bit bigger. Okay, it looks a bit weird, so straight away. Now it looks better. We are at the wrong link, so CD. Okay, now let me run the command again. So now it's running the command, and we wait for it to ask question to us. So it has finally asked the question we want to ask. So let's take a look at the same example that we consider, right? Give me the frequent flyer, or give me the flying partner with maximum membership points. Let's jump back here. Let's run the command. Now you will be overwhelmed, and you will see a lot of information here. Okay, it failed. So let me try that again. Because you need to do it multiple times. It never works with a single try, or it sometimes doesn't work with a single try. And I have passed the limit, so I have to wait for the chat model to reload. Let's give it a while, and we will come back to here again until the refresh rate has happened and I go beyond the query limit. So now let's take a look at let's take a look at the query that I sent to it, and then we will run the demo again. Sorry for that thing. It's resources and query example. So this is the query that we send. You are a helpful assistant, and we are sending it the details about two APIs. So let's take a look at this XML file. That is the metadata that we sent. And as promised, I will show you the metadata. Okay, let me make the query again. So this is the same URL, graph.sap, company, and $metadata. And as I told you, it contains the details about the entities and the attributes. So this is attribute. And if you see here, the location is like a navigation property. So someone who knows OData can easily get that. This is the point where you have to use a $expand, and LLM is quite nicely trained with OData. You need to train it again, but there's some information. So this is how it looks like. Now let's run it again. Maybe the key is refreshed now. Okay. So let's not get overwhelmed again. Now it ran successfully, and you say you are a helpful assistant who reads the metadata. As I said, we send the metadata for 2 APIs. In this case, you can send it for multiple ones, right? For example, you have data about business partner, then you have data about flying partner, then customers and catering partners, and it should be able to understand based on the query that what the data is, what the question is, and which API to choose from. And this is what we do. Along with that, I've added some information, which is very generic information saying only use $expand with navigation properties, which are for type collection. So this is generic information. This is not specific to the frequent flyer case. And this is the prompt that is being sent to the model. And at the end, I expect it to respond with a URL. So the URL, basically, it says the URL is created using entity name. And at the end, I get a URL which says the URL is /API/company/entity container /blank partner and order by membership points and top equal to 1. As you can see, it came up with a very nice query just based on the metadata, and it's already nice. But of course, as I told you, it doesn't work with the first run, or it might work, but not always. And it failed in the first run, saying that we try now to hit the URL, and we get a response saying that, okay, this particular entity does not exist in this namespace. So what do? We retry. This is what I'm doing here. In the previous run, the AI responded with a URL and we got an error. And now I will ask the AI to create the query again, but considering the error in mind. And that's what it did. So you get a response, which is now another URL, and we try to access the URL and we get a response, like a JSON response, and that's the answer here. But now, since we need to a human readable response, we can again ask the AI to generate a human readable response based on the JSON output, and that's what we get at the end. So if you can see here, this is the answer. Here it clearly says the flying partner with maximum membership points is Fast Bikes Inc., and they have a total of this membership points. So at the end, the large language model analyzed the metadata, give you the right answer, and we were able to develop a very nice application. Let's move back to the slides. And if you can see now what we did. So until now, what we did was we take a look at how to create a business data graph. Then we checked out how to make an LLM application. At the end, now I will explain what Graph tries to solve here, right? So as I already told, Graph, the metadata from Graph is a very important thing here, as it is super precise about your, it is super precise, and it does not contain a lot of attributes. So the LLM, it's easy for the LLM to train. So that way, Graph can simplify the life of an LLM application and get you very accurate results. So that's it from me, and I will just jump to the last slide as a thank you note. And if you want, you can connect me on LinkedIn, or my email is also on the screen. That's it from me. Thanks.
Thank you very much, Shardul. I really like that thank you message in the end, how you end up structuring your personal details in a JSON structure. It is amazing what some proper prompting can do to an LLM, right? Whenever I played around with, for example, that OpenAI, ChatGPT, I was always getting XML responses or Python scripts or a JSON structure. And it's funny how within instructions they provided, you basically specify, I want a human readable response and how it can output exactly that for you, right? Amazing. Well, and also it's pretty cool how it was able to process the metadata and actually by itself create a correct query. The second time, not the first time, but still, it's quite impressive, and obviously that sort of highlights how APIs in Graph are quite simple, right? And how something can end up doing some processing and outputting the right results for you. That's very good. So thank you very much for sharing your knowledge and expertise in this question. Also, thanks to you, the viewer, for joining the live event or the recording of this session. There is plenty for everyone to learn during the Oktoberfest, so make sure to check out all the sessions that are part of the event. And that's it. Thank you. Bye.
Thanks a lot. Bye-bye.